We come to the second part of this chapter, forces as vectors. So here we're going to use ij notation. I is 1 unit along the horizontal axis. J is 1 unit along the vertical axis. And we can also consider I as 1 unit along in the direction of east. J 1 unit in the direction of due north. So example 3. It says that we've got forces 2i plus 3j, 4i minus j, minus 3i plus 2j, and ai plus bj act on an object which is in equilibrium. Find the values of a and b. Okay, I would never write these individual forces in ij notation in this manner. I would always write them using column vectors. So 2i, 3j, 4i minus j, minus 3i, 2j, a, b. You will come across these before at GCSE when you're doing transformations, translations via vectors. So 2 to the right, 3 up, 4 to the right, 1 down, 3 to the left, 2 up, and so forth. Now the resultant force is found by simply adding the individual forces together. And because it's in equilibrium, we know the resultant force is 0. So that's going to form 2 equations. First equation along the top, the second equation along the bottom. So if we add those up, 2, 6, 3, 3 plus a equals 0. So a must be minus 3. And on the bottom, 3, 2, 4, 4 plus b also equals 0, meaning that b is negative 4. Okay, example 4. We have 3 forces, 2i plus 1j, 3i minus 2j, minus 1i plus 4j, and those 3 forces act upon a particle. To work out the resultant force, we simply add them together. 2, 5, 4, 1, minus 1, 3. And that's the resultant force. So 4i plus 3j, but it's absolutely fine to leave your final answer like that. You don't need to write 4i plus 3j. It then wants us to work out the magnitude and bearing of the resultant force. So what 4i plus 3j actually means is we'll be going 4 to the right and 3 up. The resultant is simply the direct distance, the diagonal distance across. So to work out the magnitude or value of the resultant force, we simply can apply Pythagoras' theorem. Now I don't need to here because this is obviously a Pythagorean triple. So it's a 3, 4, 5 triangle, so the resultant force is 5. If you're not sure about that, Pythagoras theorem, square, square, add square root, 9, 16, adds up to 25, square root is 5. So the magnitude of the resultant force, and we use these vertical lines to denote magnitude, equals 5. The bearing, to work out the bearing of the resultant force, we need to add a north line, and the bearing is then the clockwise angle from the north line to the resultant force. Now we can work that in one of 2 ways. We can either work out this angle here and then subtract that angle from 90, or we can work out this angle here as those 2 angles must be the same as their alternate angles between these parallel lines. Generally, most people work out this angle here first. So this is opposite, this would be adjacent. So the trig ratio we're going to need is tan tower. So tan theta is 3/4, opposite over adjacent. Theta is tan inverse 3/4. And then our bearing is that angle subtracted from 90 degrees. check, make sure you calculate in degree mode. 90 subtract shift tan 3 divided by 4 equals 53.1 degrees. As it's a bearing, we should really put the first 0 in, just to be precise. The final part of this question says describe the motion of the particle. Well, it's simply going to accelerate in this direction, so it'll accelerate in the bearing of 053.1. Those are the examples up to exercise 10b, so have a go now at exercise 10b.